saying it's just a matter of time and you would hit the 200 million.
You make it sound simple, but
Hi, I'm Rayan Shingati. I'm the managing partner and founder of Transition VC. With me today is Shitanshu Tyagi. Hello, everyone. Shitanshu, we invested in EMO about a year back, and EMO was our first investment from Transition VC. And this is also our first podcast ever. So, and I think we'll shoot quite a lot more in the future. So, quick brief about Transition VC. We are a venture capital fund focused on climate tech, investing in deep tech, solving real life world problems. One of the mission that we have is to offset 40 million tons of carbon emission by investing in 30 startups over the next couple of years. And to give context, this is about 1% of total India's carbon emission. And some of you all might be aware, India is third largest carbon emitter in the world today. So this is our contribution towards making India reach our net zero journey much, much faster. So that's about Transition VC. Shitanshu, maybe you could introduce a little bit about yourself and we'll dive right in.
thank you so much. Hello everyone. I'm Shitanshu Tyagi. Started EMO Energy a couple of years back. We're essentially a tech company developing an entire tech stack to significantly improve the life, safety, and performance of battery packs. We deploy batteries in everything from mobility to energy storage. And the idea is to essentially take the most standard cells possible and basically build out an entire extensive infrastructure around it. So we're a 25% team and essentially scaling up our battery packs across mobility and storage.
So, Shitanshu, tell us your story, right? Since the beginning, what have you studied, your experience before starting EMO, and what was the trigger that made you start EMO? What's the big problem statement that you came across that you thought it's worth all your time and effort to solve for?
Right. So we'll dial back a little bit to essentially when I was in college. So graduated Manipal in 2014. All through college was specifically kind of involved in automotive projects, did a lot of racing teams. And towards the end of my fourth year, essentially was very motivated to start a company because that's essentially when entrepreneurship was also booming. And that's really when I made the first contact I had with the whole concept of entrepreneurship. And back then spent almost a year and a half actually scaling a rural transportation company. So it was almost 7-8 people. We actually worked quite a bit, got incubated, and very quickly realized that we really didn't know enough to do this. So I took a little bit of a step back, had enough understanding of the automotive world, but then really decided to actually move to the US, understand a little bit more about what the most essentially cutting edge technology really out there was. So spent a couple of years doing my master's at Virginia Tech, spent a lot of time understanding electric vehicles from scratch, from a controls, modeling, and a base engineering level. And then after that, essentially got really lucky and spent 5 years working at Tesla and then at Rivian also. So there I was part of kind of essentially the first 50, 60 people developing the first R1T, the battery, the body systems around it, how really an EV company goes from 50 people to something like 5,000 people. How does that whole journey happen and how do you go from concept to production? That was something I was fortunate enough to see 2 times there. And that whole journey really made me kind of take a step back and realize that, okay, I was ready for this. So 5 years back, decided to move back to India, was essentially looking for a lot of people even then, take this forward, kind of start again. But in that process, met a bunch of people from Ather. And this is when Ather had maybe 10 or 20 vehicles on the road very early on. And decided to join their battery team. So the 450X you see on the road, a lot of that system, essentially I was part of the ground up team who designed that whole system. So also realized that a lot of the implementations I was part of there were really different from what I was exposed to in the US. So there was a very different focus on cost, very different focus on scale, safety, and essentially the smaller systems which you had, let's say 2-wheelers or even 3-wheelers, had a very different approach to get that safety performance. So understood this quite well. It's Ather, them being the most, I'd say, dominant tech company in that sector in this country. And around pre-COVID is when I essentially actually joined Ola Electric. And that's essentially when everything changed, because I also met Rahul, who is the co-founder for EMO Energy right there. And both of us then spent almost a year and a half developing that whole battery platform. And that was kind of a clean slate approach. Me and Rahul were essentially part of the key engineering of that whole system. And through that, realized that, again, if you're going after scale, where you need millions of two-wheelers, when you need 300 crores, right, like 20 million every year, how do you design and engineer for something like this while essentially keeping low cost, then giving all the bells and whistles you get globally? It's not something very straightforward that we saw that you could just take something from US, take something from China, and then just start something in India. So that whole experience really brought us very close together, me and Rahul having spent 10 years more than I have, and I'll get into that. But that whole idea of essentially developing something from India for the developing world and not just like targeting specific parts of India was really the goal. And that whole understanding that all of this now is going to revolve around the energy source, around the batteries, which then define this whole sector, was really the starting point. And yeah, me and Rahul left our jobs 2.5 years ago. It was pretty much a clean slate then, and we weren't really, we knew we wanted to do something around improving safety, performance, and just overall implementation of batteries and overall mobility. But within that, we were still very unclear. So it took us some time to actually figure out our niche and our focus within that. First started that, we'll just build some software, try to improve with the different vehicles. And then again, very quickly realized that the assets itself, the battery packs, the charging ecosystem was just so poor. The infrastructure was so disconnected that we really needed to be able to solve for the assets itself in this. So now EMO essentially develops entire battery packs for different segments, for two-wheelers, for three-wheelers, for four-wheelers, develops the most optimal asset as a battery pack, which now allows that vehicle to last for 10 years instead of the 3 years that they were running, allows them to fast charge even with standardized infrastructure without trying to implement more chargers, and essentially allows the most optimal TCO possible. And that has its prominent effect in fleet first, but then in the B2C market once it starts scaling also. Yeah.
So you seem to have achieved quite a bit since you quit your job 2.5 years back, right?
Yeah, Rahul and I were very clear, even when we started, that, we weren't really we were obviously trying to find a footing here, but we were also clear that, there are specific problems here. That from day one, and that hasn't changed. How do you maximize safety, performance, and life of energy systems? That's it. That is the sole focus of this company. And even within that, life cycle comes first.
What's the sole focus again? Can you...
To improve the safety, performance, and life of battery packs. That's it. Like from our perspective, how do you implement the most optimal asset for an energy system to basically scale across mobility and then even energy storage? So we started with two-wheelers because we felt like that was a low barrier to start. The market essentially had a lot of startups. It was fragmented in nature, and there were different people to scale with. So implemented, even within the first 6 months of our kind of origin, a couple of small prototypes with fleets, have been testing for almost a year and a half on road. So that idea of iteration from very get-go was very strong. We built at least 15 different prototypes since then before we even homologated and certified what we did. But yeah, the focus on building out the entire tech stack from day one was very clear. And yeah, we've just been very consistent on and focused on scaling that two-wheeler system first and then going to larger vehicles.
So a couple of points you touched upon, right? How large the whole Indian market is and how cost efficient it is. And it is important for solution that you provide to this kind of market. It has to be cost efficient. We'll talk more about it. But before that, you said you were with Tesla, you were with Rivian, Ather, Ola, and then started EMO, right? So it seems like you are probably the best guy out there based on your experience to actually build this solution. And you've been working on the battery solution for all of them. You've also seen and joined these companies when they were fairly small and seen them grow. So tell us a little bit more about your experience in Tesla and Rivian and even Ather.
Right, yeah. And just to touch upon that a little bit, the reality is that it only starts obviously with me. There's like a 25% team to support the vision. But yeah, from my perspective, having gone through these companies has kept very clear clarity on what we should focus on from day one, thus allowing us to move quite fast. At Rivian, I was literally in a shed in Michigan when they started. It was 50 odd people. And at that point, just that understanding of how big we should be thinking was very important at that point. So they were thinking, okay, that they should be building an entire infrastructure for personal vehicles and also link that to commercial, have a platform which then can scale across different systems. So having been part of that ground up approach was pretty unique. I was in touch with the whole founding team who was there and really built out that system over 10 years, right? Because that company took obviously a long time to become how big it is. So how hard they worked, how focused they were, just how much work and time went into it became apparent to me from the inside. And it's a lot more than people anticipate, right? Like people think it's like a little bit work, but yeah, the core team, the real people there were 100-hour weeks is normal there, right? And that understanding of, okay, this is a really large vision which we're going after, that really sunk into me then. And from a technical perspective, they were always very open to just failing. Like, okay, you have to kind of put something quickly out there, iterate, and then move on. That was also, in fact, the same thing I saw at Ather and Ola in different ways because it was different segments. But I, fortunately enough, have been only part of companies who have been that aggressive about just growing fast and about having like a very, very, not just big vision, but also very key execution plan, because you can keep talking about vision, but knowing that, okay, we need to move quickly, but in a very specific manner, and knowing that there's not that many times you get to do this. Like iteration is great, but 3 or 4 and not like 20 times you're just sitting in a lab. Moving quickly on road, implementing with the customers, taking feedback. That's something, for example, Ola did really well. And there are a lot of complaints around service, but the fact that they were quick to get to market has allowed them to scale, right? Like they're iterating so quickly that there's 7 models now. Nobody has that within the period. I left from Ola. Like I had just seen S1 Pro when I left, but the idea is that that really becomes the key mode. So for us also, we started with 2-wheelers, but we have everything ready now. We have 3-wheelers, 4-wheelers, tractors, larger companies are also working with us for that. But the idea is that you have a specific kind of approach already laid out. And it's very important in those decisions then just keep getting implemented, because it's such a large web, right? Like I make one decision and then 25 people have to execute something, and that keeps flowing. So yeah, we've just been very focused on getting battery packs for 2-wheelers in the market, getting a bunch of revenue from that, and then scaling to each of these very systematically and as quickly as possible.
And so EMO's at 25 people today, and it's poised to, and you aspire to build it as large as all these companies that you've worked at, right? So would you say you've gotten some takeaways from Tesla, Rivian, Ather, Ola? What worked for them and what helped them grow from a 25 people to thousands of people? If you want to touch base upon a couple of those points that you have learned and want to implement and help EMO move from 25 people to a thousands of people organization.
No, absolutely. In my mind, there's 2 things that matter over everything. One is product excellence. Like you have to be solely focused on just that in the beginning. And the second part is building a team around it and keeping the team as lean as possible in the beginning, because it's very key that to a certain extent, once you start growing, obviously there's a lot of people that, just overall reduce the level of, I'd call it just passion, execution, whatever that is. But making sure that every person is contributing a certain amount of work and all of that gets translates to execution is very critical. And for us, that all of that comes down to product. Like how quickly we get the first proto out, how quickly we get that to the first system on road, how quickly do we get to 1,000? And as we're doing these, how do we maintain quality? How do we maintain performance and actually make sure that the customer wants us back again? The door to get into a customer in the fleet or even the OEM side to do a pilot isn't that hard anymore. But the team's focus on the product, making sure it's reliable enough, even the first day they get it, helps us with like overall retention, and that really matters here. So yeah, for us, all like most of the money on this ever from this company, or even most of the effort, has just gone in refining everything from the tech stacks perspective. Like we've been very focused on that, and just we're making sure that all the people involved know that what they're implementing is the absolute best there, and knowing that okay, everybody else's system is something, we've implemented this for a very specific reason. It's not that just this was the best thing we thought. No, this is the best. We're clear. That has been very critical.
This is the best. So let's get into that, right? Let's talk more about product and your approach. There are a lot of battery pack assemblers out there, and when we build a thesis to invest in this space, we were very clear that we want to invest in a technology that is significantly different from anyone else who would just import cells, put it together, and put it in a vehicle, right? And that's what caused a lot of problems in the past, as we've seen, and what the fires and everything else. And we'll touch upon that as well. So, about EMO and the battery pack that you have built, right? How are you not just another battery pack? And what is that differentiator? And how does it translate to result in terms of life cycle, in terms of the cost or safety, and those top 3, 4 parameters that you focus on? And how has the battery fared on road? Now you have significant batteries on road, right? You are making significant revenues as well. So tell us more about how are you different from anyone out there, right? Like you said, it's the best. How are you the best out there?
Right. So I'll focus on each of the elements of the tech stack, but starting with the most important thing here is the cell. So today, pretty much everybody buys cells from China, Korea, or some even from smaller countries here and there. But the reality for our country in general is going to be that for the next 5 years, even more, most of our cells will be imported from China, and a fair share of them are going to not be the best cells in the world, because the best cells will go to the US, will go to Chinese passenger cars, European vehicles. So a lot of this country today does use grade B cells, or even grade A, the lower scale of cells. And those have a significantly lower life cycle, those have a significantly lower charge capacity, and overall don't really offer that whole 1 rupee per kilometer number we're dreaming of. When you build out a system, they're dying too soon, the reliabilities are questionable. Overall, just a very hard system to implement at scale. So we first took a look at this and realized that if we had to basically scale as a market, how do we buy the absolute cheapest cells possible, which is, let's say, even $60 a kilowatt hour, or whatever the lowest number there is today, and now build out an entire ecosystem around it, which then supports higher TCOs, higher life, and then overall gets this asset to the maximum life possible. So we built out an entire software platform, which essentially really on a granular level understands what cells are going through. So we've been able to visualize how plating on cells is happening, which is essentially the loss of lithium on cells, which then overall leads to lower life cycle. We've been able to see physically on how that happens over time and over the entire voltage range of the curve also. So we have a very specific and a sophisticated software system now, which on a very, very detailed level is really able to kind of show you how the cell is performing over time, and also now predicting how it's performing over time. This understanding then now paints us a very clear picture of what that cell is capable of doing. This itself is the largest element for us, because this understanding and this monitoring of what is happening is really not there today. There are a couple of companies globally like Breathe and Glimpse who have tried this, but that's where they stop. They might paint you a basic picture, but the level of detail we have is because we're a battery full stack company, which brings me to the second point here. So you have a clear picture and you monitor your cell well, but now how do you control this? How do you improve something? Now we have an entire cooling system and an entire kind of battery management system, which then is able to control each cell in the whole system to exactly what we want it to be. So over the life, over the range, we're able to control temperatures within 1 degree. We're able to control each individual cell's current and temperature, thus making sure that the overall performance over time is controlled. So this entire kind of 3-level approach that we monitor it, then control it to the management system, and then also control temperature, now allows us a very key kind of tech stack. And there's companies who do kind of cooling systems. So there's Chrysler, there's Zinc globally. There's companies also do BMS. And the reality is that now combining the best of each really allows us such a strong kind of overall platform that wherever we go and implement this for whoever sells us, whoever application, they're going to get the best bang for buck. They're going to essentially get a pack which might be $140, $50 per kilowatt hour, which is the global standard, but still get like 8 years warranty, 10 years warranty, still get 30-minute charging with standard sockets without anything special in the charger. This is the biggest moat for us. Like, how do we scale the entire battery pack with all of these combinations combined across different OEMs, which essentially allows them the global cost and then allows them much, much significant performance. So from a global perspective, we're at least 40 odd percent cheaper for the kind of performance you're giving. This is not just even like an Indian claim. We've studied a lot of companies globally to understand this. And yeah, this key combination of the software monitoring, the cooling system, the entire thermal controls around it, and then the battery management system is really what separates us.
So to simplify it further, right, for a lot of people who don't understand the technical very well. So you're saying you can make the dream or the target of 1 rupee per kilometer possible. And that is what EMO can make it possible.
On a system level, like considering all your charging costs, considering your like, overall system costs. And this is what we've been able to present to fleets also. So we have a battery pack, which at its core level is the best asset possible. You're going to get 10 years life out of it. We've designed the system to be able to tolerate fast charge, tolerate abuse, and very high levels of safety. So we're keeping uptime really high. We're essentially charging this within 30 minutes. We're keeping the charger count really low. And overall, just keep that asset life so high that you essentially just amortize this over 8-10 years now. So for us, the rental is spread out so well that we really are able to present the best TCO possible for some of these.
So basically, you're saying the tech that you've built, the architecture, the liquid immersion cooling, the BMS, and the controls that you were talking about, right? So the tech that you've built is essentially enabling a B-grade cell that you have access to, say, at $60 or $70 per kilowatt cell, perform almost at the stage of an A-grade cell, which cost about $140. And that is the differentiator that EMO brings. And that is the tech differentiator versus every other battery pack out there who is just assembling.
100%. And that's a very key point we touch here, because today I could go out and buy Samsung cells or CATA cells, which warranty 3C, 4C charging, right? Like they can do 15-minute charging, 20-minute charging, and still give me 2,000-3,000 cycles. We can buy those cells today, put them, and we just now need to be able to reject all of that heat that essentially builds up. That is easy to do. How do we take the cheapest cells from China, which essentially basically, let's say, are they reject cells for that matter, not from a quality perspective, but from an overproduction perspective.
Okay, even reject cells.
Yeah, how do we take like low capacity cells which have been lying around for 2 years? How do we extend life for them? How do we essentially see on a more granular how to reduce plating, only charge in some components, and then get to the point where we're essentially taking these cells and producing, let's say, LG, Samsung level performance? Because if I start using those cells, I am going to be at $180, $200 per kilowatt hour on a system level. And that then starts pushing it to the point where it doesn't really make sense. And that is the key differentiator here from anybody's kind of perspective from the market.
So let's talk a little bit about OEMs, right? Sure. So a lot of times OEMs are either building in-house, some of them are outsourcing also, right? And it depends. So India is such a cost-sensitive market, especially for two-wheeler, three-wheeler, and to achieve that 1 rupee per kilometer, which makes a biggest difference, especially for fleet, right? So so you have a few customers, right? So what are those points that they loved, why they signed up on you? And what are the challenges that you see from an OEM point of view to accept someone like EMO versus a traditional battery pack assembler?
Yeah, no, that's a good point, because there's obviously a lot of battery companies, there's a lot of OEMs, there's a lot of cell companies, and all of them essentially do build finalized battery systems. And
so one sec, OEM is basically a two-wheeler, three-wheeler, or a four-wheeler if someone...
Original equipment manufacturer.
Yeah.
So the idea is that if you take, let's say, a continent like Europe, which is scaling similar to India, like they buy cells from China, put them into systems, and then implement them, 30% of that market is still outsourced to battery pack companies. 30% or so goes to just the original vehicle company, and then the rest goes to the cell company. And even within the 60-65% that goes to the vehicle and cell company, we're actually able to see that 50% of those systems are engineered or licensed to some battery pack company.
Okay.
Because
this is globally.
Yeah, this is specifically Europe also. Like Europe, if you take, because their market, again, China's a hard market to take because it's just very different in nature.
So
but
why
Europe
is that
very
50% outsourced, and what are the reasons why the other 50% is in-house?
Right.
So how do you see this changing, or do you see this changing over the next a few years, and especially for India?
Right. So there are two approaches, right? One is where OEMs want to vertically integrate. They basically want to keep control of everything so that you have a very, very tight control on cost and the overall quality and performance. But the reality is that most of the automotive structure is still horizontally integrated. And today, the biggest issue from an OEM's perspective is that if we were to give this system to, let's say, an XYZ battery company, they would essentially never meet our cost targets or meet our quality or warranty or liability targets. And this becomes much harder than to give to a startup, because if you're working with the likes of Tata, Mahindra, TVS, or other top tier OEMs, their supply chain and production system is so clearly defined and very well controlled. It is almost impossible for a startup, even in a few $1 million, to essentially scale to that level. But what really separates, I think, startups starting or even companies from a battery pack perspective is that unique blend between three focused engineerings, right? Mechanical, electronics and electrical, and then software. These three blends are not that common to see in a cell company, which is more focused on chemistry and materials and how to design the cell, or even in an OEM. Like they're building a vehicle, they might have these three functions, but on a very vehicle level. How this applies to cells, how this applies to building out a very strong battery pack is your own specific moat now. And obviously, a lot of vehicle companies have hundreds of people in their battery pack team essentially doing this. But over time, you're going to see companies that can essentially modularize 2 or 3 standard systems, which might be kind of different based on chemistries and sizes and applications, now building out modular common systems for multiple OEMs with specific nuances. So I might have one fast charge system in a two-wheeler, 3 of those can go into a three-wheeler, 100 of those can go in an energy storage project, and 10 of those can go into a tractor. But you have some basic tech architecture on the hardware, on the electricals, on the software, and lastly on the tooling and capex, which now allows you to standardize a lot of this. And this now will drop costs so much going forward, because I, as a battery pack company, will buy 2 or 3 different cells for 10 different companies versus them buying their own cells, them building their own teams, building their own systems to produce almost similar or slightly different systems. Because we, as a pack company, with the experience we're bringing, with the kind of tech we've already been working on, already feel like it's a couple of years at least ahead most OEMs, if not more. But that edge and that speed at which this market is moving, we as a tech company in the battery perspective can do a lot faster. And we're already seeing that happen. So even OEMs who are not so interested in the beginning, who thought that this is, okay, maybe just another startup, are seeing the value in this stack really being able to put into certain vehicles and then scale over everything over time. Because especially for large OEMs, again, technology is just the starting point. Your product excellence is just one step, and you have to get that 100% right to then move into 100 other things after that. So I'd say with smaller OEMs, we've already kind of tracked a lot of this. We're moving into mid-size OEMs already. And the really large old school OEMs, we're actually starting to do some of these projects also.
So basically you're saying it's almost like a no-brainer for a lot of OEMs to move from not having in-house and giving it to vendors like you, especially those who don't have a very large scale.
Yeah, and even for the ones who are very large scale, like Tesla, right, is the largest vertically integrated company in the world. One of the only components they outsource is now their battery pack to CATL and even to BYD. China, they were doing that, and now even the US, they're doing that. And the idea is that if they're able to give 3 targets on performance, cost, and just overall implementation, if it's very clearly defined, it doesn't matter where it comes from. It matters how well the company you're working with is actually able to integrate a reliable system, which has absolute the lowest warranty issues, right?
So you're saying it makes sense if, like, since Tesla is doing it and they're the largest, or even the larger OEMs in India could perhaps move that way.
Right.
What are the challenges? Why are they not moving right now?
So I'd say there is already a split today, right? Like a couple of the largest OEMs in the two-wheeler sector obviously do it in-house. And that also is because in the beginning few years, the speed they wanted to get at, the level of technology that really didn't exist in the rest of the market is what they were able to implement quickly. And
you're saying that was the need of the hour, so they did it themselves.
And they had to,
so eventually, when they would get at a scale and there's a good solution like what EMO is providing, they wouldn't mind.
I'm seeing those companies also move into that direction for certain components. The idea is that this whole battery pack business is just so noisy that there's just a lot of things they need to test for. And for a good OEM, it's not like, I'll just test for a month or so and just get out in market, right? It's a long process. You have to go through so many stages to get to the point that, okay, now this is ready to go in one person's hands, 100, 1,000, and like 100,000 people's hands. So a risk like that for an OEM that large to take is not straightforward by any means. But only companies who've been through a very specific, rigorous engineering process validated all their systems on roads for lakhs of kilometers, can then go with confidence in saying. And we, for that matter, have been very specific about this. That saying that, okay, we'll start with small fleets, we'll start with small OEMs, get the system right, then keep moving up this ladder chain. Instead of saying that, okay, we're going to the best the first day, it really isn't possible. Physically, it's just improbable
So
to think of.
credibility is everything for them.
And just real world data over time. And because credibility can be achieved multiple ways, but overall, just making sure there's real testing, right? Because bigger OEMs, again, they're going to test them themselves. If you fail once, it's out. There's not like, oh, I'm going to get 3 tries. This is pretty intense. So,
And a lot of these OEMs, some even bigger, some not so big, probably rush to the market very, very soon. And that caused sometimes significant safety hazards, fire mostly. And we saw that in the newspaper quite a lot of times. This also led to the simple average consumer to rethink to move to EV, even if it made sense, say, from a cost-wise, right? So even if you're able to promise that 1 rupee per kilometer, and that's what they aspire, but safety is even more important than saving some money. How do you see your product, your tech, your battery is solving for fire or safety hazards, which is still a very big question for a few people? And why does it even happen? Why do fires? Let's start with that. Why are there fires on EV vehicles?
sure. So, we'll take a step back to just understand why fires happen, right? So, electric vehicles are built up of 3 or 4 major components: the battery pack, the motor and controller, and the entire charger system. So, there are 2 parts to this which essentially lead to fires more often than not. One is the charger, and then the other is the battery. A lot of charging kind of failures in the past have led to fires where the charger itself used to overcharge the battery, or there might be a short circuit issue in the wall, or the wall itself caused issues here and there. But a lot of those have actually got a lot better in the last couple of years since when the new regulations were formed. So initially, a lot of the fires mainly happened because battery packs were just dumb. They really didn't have anything smart. They had very basic cutoffs. Across an entire battery pack system, you have hundreds of cells. You're really not able to monitor all of them. You really don't know temperature, voltage, and condition for each one of them. So it's almost physically impossible unless you've designed really well, and you can with very, very high accuracy. And I know everything even without measuring, which is very improbable. So from a first perspective, you had charger failure issues, which are kind of gone now. The second issue is that, okay, there's a lot of cells in this battery pack, and you don't really know very well what the temperatures are. And now you, let's say, put this in more abusive and more, let's say, high ambient condition kind of situations. Now, if your battery pack is essentially performing consistently at 45, 50 degrees, and you're kind of going on utilizing it there is a high probability that the gradient within that can still be much higher. This leads to situations where certain cells over time degrade more and then essentially catch fire. Plus, a lot of the cheaper cells which used to be used and are still being used are just so low quality and are not really monitored to know if they're degrading fast enough. So they might have cell quality issues where the understanding itself and the prediction is not there. And even if that cell blasts open, there is nothing to protect it. So there's just 3 layers to it, right? Like you have your first, you need to understand what's happening and you don't know. Second, a cell has started to basically degrade because it is bad and you still don't know. And third, that's actually blasted open and there's nothing you can do. You have to solve it each layer. And knowing that the cell might be bad, you have to still solve for each layer. So the first step is check everything. Like you in factory itself have a lot more rigorous testing, not just what the government is mandating, but actually see on a granular level what's happening. So scan cells from a more physical perspective and understand on a granular level if there's contamination or issues. Second, when you're in putting cells, monitor everything. Like even cylindrical cells.
EMO is doing all of this, right? Control, monitoring.
Each of these essentially is what we do, but these are the key solutions to what make our system better. And even if somebody else is trying, these are the key problems they need to solve for. Second, you monitor everything, understand temperature, voltage for every single cell, resistance, how it's degrading. Do you really know across the whole cell? Are you using very large cells where you don't know the gradient? The third part is that now, even if cells blast open, know that it's going to happen and use something to basically make sure you can mitigate that. And that's where a cooling system or a fluid-based kind of thermal control system plus an active kind of venting system for all that gas and extra energy comes into play. So check, monitor, and then control essentially become the three key parameters. So for us today, even when one cell blasts open, our system knows that this is going to happen. So it puts all the pumps into overdrive, very quickly starts rejecting all the heat from the fluid, and then keeps that vent ready and open. So once the cell blasts, very quickly reject all of that. It comes out as basic gas for around 10 seconds. And you're sure that that energy from one blast is not spreading to other cells. And that is the key to making sure you don't have giant fires. Because everything we've seen over the last 6 months is mainly because of this. One cell blasted open, it hurt other cells, multiple cells then started catching fire. And this thermal runaway process has basically now ignited your whole vehicle. So how do you contain that one cell's energy once it's blasted? Make sure that it quickly rejects it and make sure it's a safe system is the only real way to prevent this from happening. We're always going to see lithium be a slightly high risk product. There's solid states in the future which guarantee something, but till it's really commercialized, we have to live with what we have.
So basically you're saying EMO's battery packs are safe for probably safest out there in the market.
Absolutely. The focus on making sure each step of this is really right, like the architecture, the controls, the monitoring, we have really gone all out. We've designed our own temperature sensors. We've put a sheet of a temperature sensor which measures every cell. We do active balancing BMSs which control voltage for every cell.
Let's talk about chemistry agnostic. So how do you see the future of EV batteries and cell chemistry, right? So there is so much going on. So people say, is EV the future? Some talk about hybrid, some talk about hydrogen combustion engine, different fuel cell, etc. Right? So without getting into detail of different applications, and what we believe is every technology will have certain applications, and there is a certain winner, which is EV in these applications that we're going after. But even within EV, right, there are different cell chemistries that keep coming. So we saw lead acid at one point, and those Delhi e-rickshaws that we see which ran on lead acid. And then came lithium, different cell chemistries, lithium, NMC, LFP, etc. People are talking about sodium, semi-solid state, solid state. How does this technology innovation or say progress, evolution affects EMO? Does this drastically change the whole tech that you've built around? Is it focused on just one cell chemistry, or even if this changes drastically, will EMO's solution continue to be relevant and significantly relevant the way you're presenting today?
Yeah, no, it's a very important thing to look at, right? Because this market is ever evolving. Like we have obviously so many directions, even other than the electric prominent direction, that it's important to realize that just overall lithium batteries, which are the fundamental core of electric vehicles, are here to stay in one way or the other. We feel like there are so many advances happening within that and for different chemistries that there might be alternate solutions in the future, but at least for the next 5, if not 10 years, different versions of lithium chemistries will dominate most of mobility and most of storage. And there might be alternate solutions out there. So let's say there's sodium, there's graphene-based batteries, there's different worlds of chemistries, like some people talk water, sand also kind of producing it. But the reality is that any chemistry that exists will most likely be implemented as a battery. So you might have a certain cell, which might be any form factor. It might be round, it might be square shaped. And those are lithium today. Within the same form factors, those might become sodium tomorrow. Those might become some other material.
How does it affect EMO? So if it becomes sodium or solid state or semi-solid?
So the reality for us is that the cell is just a box with certain data for us. Like we treat this as a certain energy source. It's producing a certain amount of energy. It's producing heat while doing it. It has certain characteristics and performs a certain way over time. That understanding is core and similar to any chemistry. Like no matter what you use, there is going to be a certain way that cell behaves. And for us, that core understanding of monitoring and then control kind of is chemistry agnostic. We can implement this for different versions of lithium today. So you have the ferrous phosphate cells, you have the nickel cobalt cells, you have different versions of sodium today, which have already come up. And we've already put these cells to a very specific cell kind of testing architect kind of arrangement that we have. We cycle it a very specific way, understand specific data points, and that translates to everything. Once we understand that for lithium, we're implementing that for sodium. Anything that comes in the future, we'll understand that and implement it for it. The idea is to be the absolute most optimal architecture around cell chemistries, no matter what they are. And we particularly do believe that battery cells are the future. The 90% of this market will be that way. The costs are amazing. Like lithium is down to 60, sodium will be down to 40. Lead acid is that cost, so it just destroys that whole segment. And after a point, even for a segment like India where fossil fuels are so expensive, this now makes the TCO make sense. This actually gets it right.
So you're saying EMO is absolutely cell chemistry agnostic, and your architecture and the tech that you built will work even if the cell chemistry changes. And you've tested it already.
Right. Yeah. Today we've tested it for multiple versions of lithium. We've tested it for a couple of sodium chemistries out of China. We're also now starting to test some kind of silicon anode cells.
Nice.
But the focus will always be how do we understand these cells for what they are? Because at the end of the day, cells are magic, right? Like they're producing energy with
Cells
like
are
cathode,
magic.
anode. Yeah, they are. Like it is true. Like they're just producing energy in a specific way because of certain materials actually reacting a certain way. Understanding that visually and creating a data flow around it to then implement in a system is what is critical to EMO. And that whole chain of taking a cell, implementing it into a final system, and then monitoring that over time to improve that system over time, that is something very key that most vehicle OEMs or even cell companies are not going to be focused on. Their objective is to get the vehicle and the experience right and to get the chemistry and the quality of that cell right. But linking those two from an energy perspective and a TCO perspective and making sure you have charging speeds, you have safety, those come to us.
So let's talk more about software and how important is software integration in a hardware product like battery pack, right? And can you perhaps predict life and life cycle? And that's what you're saying, right? One of the key differentiator. Now, if you're actually able to do this and you have data for it, a lot of challenges that we're seeing for EV adoption could be solved for, and we would see a much faster adoption. How do you solve for this? Or tell us more about how are you able to predict life and extend the life of the battery or the cells that electric vehicles use today?
Yeah. So let's take a standard lithium cell. We first things first basically put it through a very specific kind of cycling process, which essentially means that we put the cell in a power source, keep charging and discharging over a certain number of cycles. We've done this for hundreds of cells. We have a data bank of literally 200 cells which have gone through this process. All of that data bank on a cell lab level is then basically run through a machine learning model.
Okay.
That model is essentially understanding patterns of degradation, understanding how these cells reacted to specific changes in temperature, in current, in conditions. So we are specifically changing these, getting all this data bank, and now creating a model which basically tries to predict how the system is functioning in the future. Once we have all the cell data, we're also now using specific cells and packs and getting all of that data on the road. So we're taking two-wheeler packs of our own, we're taking other people's packs as data, and again crunching all of this data to at a very visual and graphical level understand how these cells degraded. So within these different chemistries, we can see different patterns, different types within those chemistries, we can see specific patterns. And now after kind of training our model with a lot of these, we can actually predict what kind of pattern this vehicle is going to have. So let's say both of us own a Tata Nexon. I am a very aggressive rider. I basically ride 200 kilometers a day and I ride it very fast. I fast charge all the time. And you maybe ride 20 kilometers a week. You're slow charging. You're using your vehicle very calmly. Our EMI should not be the same.
Okay.
Our insurance should not be the same. And for electric vehicles, this really doesn't come down to the vehicle. Your tires might degrade, your brakes might degrade, but the battery pack is the first thing that's going to die for me. And it's going to die much sooner for me than for you. we shouldn't have the same warranty. We shouldn't have 3 years warranty. I should maybe have 2 years warranty. You should have 8 years warranty.
And right now in the industry, it's standard.
It's
5
standard,
years,
yeah. It's basically somebody gives you a kilometer rating in years and that's it.
So you're saying your data could help insurance companies, financing companies provide real solutions
Right.
to customers.
And it's the active and understanding the differences is one thing. But today, banks don't even want to be financing this because their understanding of how this system scales over time, the reliability of this, the real value of extending it is just absent. They're seeing so many issues, they're seeing so many problems on ground that they're all just playing the waiting game. And if all of us keep playing the waiting game, we're just all waiting. Like, so our focus is that we'll come from a very key battery technology perspective, link with certain financing companies and provide them the software APIs in the platform for them to do underwriting for batteries. Because the future of this whole industry, especially on the B2B side, really comes down to doing this. And not just at, okay, like I'll take your battery, I'll test it for 3 months, then I'll take this vehicle, test it for 3 months and come back to you on what this should be. Active, within 5 seconds, you pull up to some station, put this and then get a health report.
Wow.
And then that whole model scaling across to where you have, let's say, a CIBIL score kind of standard for batteries and a rating which then you can provide to different users on how they use their vehicle. First really matters in the fleet segment, but then over time will matter for everybody because the reality and the beauty about electric vehicles is this, like you can actually optimize usage, you can improve efficiency and get to the point where you can really use your vehicles for unlimited amount of time in the big scheme of things, till where the vehicle dies first before your battery pack. So yeah, the extension of life is the focus here.
So one of the biggest challenge for someone to buy an electric vehicle is the upfront cost.
Right.
And the debate always is the total cost of ownership makes sense, which is basically the per cost per kilometer over a period of time. You were saying, look at it from a more grander scheme of things. What EMO has done is built a platform where there are a lot more solutions that are required to make it even more optimal. And that is something that you bring to the table to achieve that 1 rupee per kilometer.
Right. Yeah, absolutely.
And this would solve for the financing and insurance problem. Hence, we would probably see a much faster EV adoption. And EMO would enable that.
Yeah, because the big difference today is that, right, that when I buy a vehicle, it's always a little bit more expensive upfront. It's really not giving me the same value over time that I might be able to use a petrol vehicle for 20 years. Like some of them are, trucks are being used for that long. There is no way somebody can be using an EV without replacing battery packs for even 10 years today.
And EMO can make it possible.
Yeah, and all the four-wheeler fleet companies we work with essentially are replacing systems every 2-3 years. That really doesn't play in the long run. And even if you're doing it, it has to be very, very tightly controlled to where at least you get that 3 to 4 to 5. And then within that, get a better utilization rate. So for us to see this market playing out, we believe that a lot of companies will be able to implement good vehicles. They'll also be able to implement a good charging infrastructure because that's becoming more standardized. And you see a lot of oil players and a lot of major, even PE companies doing that themselves now. But technology to link these two, technology to link the discharge on the vehicle side and the charge from the wall side is all on the battery. This will be the key difference going forward for most companies. And for us to be able to get to the costs and technology where we can scale this across multiple OEMs, allow each of them specific advantages. Like, okay, I want better life. I want really, really a good life. I want better charging. Those really is going to be the focus.
You can optimize that per the requirement.
Because we use, let's say, $60, $70 cells, 80. We can basically get 6,000 cycles if you wanted. There are cells to do that. The idea is that today, most of this market needs 2,000 to 3,000 based on the application. And that's what we're providing with cycle life cells that give basically 1,000, 1,500 cycles. So that focus on implementing our own system first and then scaling that as a technology in other people's systems is going to be the objective.
So you've worked with a few financing companies, right? And they have in the past worked with a lot of battery companies, and they continue to work with you and a few other battery companies, and they're financing the batteries essentially. How has your experience been working with them? You partnering with them for EMO batteries financing, and how has their experience been working with every other battery pack assembler?
Yeah, so In the last 3 to 4 years, a lot of 2, 3, and 4-wheelers have gone into different applications. And I'd say most financiers have tried to do the cargo and commercial part of this first. So in each of those 2, 3, and 4, most, if not all, companies have done 24 to 30-month leases. And it's a fairly standard approach, and it's 18 to 20% to even higher IRR levels.
And it's so high because the TCO still makes sense.
No, and the reality is that they can't go any lower, and I get it. Like, because they're doing this based on just the fact that they want this market to grow. They're taking a bet. It's almost like you taking a bet on me. Like, that's the kind of bet they're taking, right? They're just hoping that, okay, we spoke to the team, we saw a couple of results, we saw a couple of test pilots, looks good, let's go. And they're financing something, even in that perspective, for so much longer than they have any visibility for. So it's a big deal to even start knowing that, okay, I have very little understanding of what's actually happening. I'm trusting these 3, 4 odd companies based on some experience and some talks here and there. That isn't really going to scale to when you come to really major banks and when you come to very well-financed, the SBIs of the country, right? So because they're looking at very, very detailed diligence reports to really now be able to say that, okay, I can finance this for 3 years to start. I know I can get this to 5 years. I know I can get 10, 12% kind of financing for this. It's just very difficult for them to have that upfront understanding of data. So a couple of financing companies and even a couple of battery companies have taken the approach that, okay, we'll take the initial samples from the vehicle and battery companies themselves, put our own testing procedure on this for a couple of months.
Testing it.
Yeah, and
that's
hard, right? Like, and that's required too, because how else do they know? They have to put it through their own kind of
traditional bank would actually get into that level.
They're not a battery testing company, and it's never going to happen, right? And it's great that some companies have been able to see this niche and actually capitalize on it. But the reality is that how do you know with a couple of key tests, and how do you really be able to generate a report which has key identifiers which link to finance and the technology? Because there's a very large broken gap in those two. That really doesn't exist today. Again, a couple of people have tried this from a very analytics heavy perspective. That, okay, we'll take an IoT module, we'll like strap it onto the vehicle and battery, we'll get really detailed analytical data,
does that work?
Analyze it and implement it. The reality is that no major OEM or no major company is going to give you that detailed data. Like, I wouldn't to some other IoT player, because there's so much key sensitive information that you really can't be giving the whole picture. And if you, for IoT based companies who are just doing key analytics from a very data analytics approach, they're not going to do anything with very basic, like minimal data. Okay, I only got voltage and current for life, nothing else. No cell level data, no temperatures, nothing. You can't do anything.
You need a complete monitoring and control.
Most of them need a very, very detailed picture to then do something with it. Our focus has been that we've trained our model with so much detailed data in the background from all the cells we have, from all the packs we have, from all the market packs we have, that we built a model to now take the most basic level data, create patterns, and then see what this actually behaves like. That differentiation and approach, where we're building like a very strong software model which does voltage analysis, which does all these key specific kind of learning approaches, then differentiates this, because it's not an IoT system.
This could be a great platform for, like you said, like plugins or even perhaps as APIs that you
It has to be, yeah. No, it will be also, right? Like, we've already in touch with a couple of financiers who are using this for some of their older vehicles. So literally a company has a 20, 30 vehicles sitting around. They can go do a quick battery health report check instead of like removing it, putting it on a bench level, testing it, then opening it. None of that is going to scale. Like, this is not.
So you can give a health report
and very detailed level, right? Like, we're able to, even for standard packs, if we have voltage and current coming in, we're able to see those patterns within that charge cycle. We'll kind of know what cells in they used anyway, because most of these are standard, and just use that data to link this really well. So we've done this for a couple of fleet four-wheelers now. We've also done this for obviously a bunch of two-wheelers. But the focus is really on larger vehicles which are doing very higher kilometers per day. And how do you now finance a truck in Chandigarh different from a truck in Tamil Nadu versus a truck somewhere else in the world which has different climates and conditions? Because even if you're, let's say, riding different environments, different conditions, how do you really optimize this data? And again, I know people who are trying this, but the level of granularity you have to get to can only come from an integrated battery company. Like, if you don't build the system of yourself, if you don't have understanding of your BMS, if you don't have understanding of how software links these. If you're just thinking that I'll just base an algo and just give it to someone, we've not seen that scale. Like, and even Breathe, right? Like a UK-based company doing really well, like scaled a little bit. It's just going to Volvo now, and it's great. Like it's going, but if they had built out a more integrated approach where they had got all this data from road after having tested tens of lakhs of kilometers, which is what we're focused on, it's a very different world. And it's something we feel like we don't want to push so much in OEMs also. If they use it, it's great. But all the other key ecosystem players involved here, like the insurance company, the finance, who are not even looking at this yet. How do we get them on board and really get this to work?
So because just an analytical company, it is really hard.
Because you're neither. You're not a battery tech company and you're not a financing company. Getting those together is the key here. And we're not pretending to know financing really well. We're not like a 100-year-old bank that actually understands this well. But we're saying we understand battery cells and the technology behind it really well. So let's get these two, fuse it, and now create an underwriting standard for the future.
And someone who sees this as a massive opportunity and wants to finance would work with you and finance your batteries.
Yep, and that's started. So we have almost 500 systems asset financing on road today.
500 on road.
Nice, nice. Just specifically in fleet, other than the OEM systems. Nice. But those are really collecting a lot of valuable data to show to these fleets that, okay, either own systems, this is working so well. We've taken all the risk on us first. We're not saying that, okay, this is this batteries company. We're not really underwriting the risk. All the risk is on us in this. We get that confidence in all the key players involved, and then kind of take this to the next stage.
You also give these financing companies a kind of a warranty.
No, 100%. That's the only way this works. Because the risk on performance and the risk on overall, warranty has to be on us, right? Like today, the financer doesn't know. They can keep it on their books financially, but to keep the risk from a usage perspective has to be on us. And we want it on us.
And you're confident that you could because
there's a bunch of lab data. There's a bunch of on-road data. We have to almost 700 life cycles. We're seeing only 4-5% degradation within that. And where standard systems would have gone 20-25% already. So a lot of, I'd say, data that's already got crunched for around 2 lakh kilometers. In the next 6 odd months, we'll be testing tens of lakhs now as we start to scale. But the real benefit to doing what we're doing is that we're getting the assets right first, getting people used to a different level of hardware, trying to systemize, to kind of get this as a system to different companies from a pack sale or even technology integration, and then over time become the software standard for most of these players. And
so you want it to be like a software standard?
100%. Because there is a credit score. Like today you have Edmund's car reviews, right? Like they'll give you a used car review. It's not possible for them to do that for electrics. Like they might, again, take the vehicle in the service station, do a very detailed check, charge, discharge multiple times, compare it to original manufacturer performance. All of that is possible. But how do you real time from nowhere in the world give that data to a customer and quickly link that to a software for all these people involved? That is the focus here. And quick loan disbursements, quick EMI upgrades. When you change riders in the fleet, EMI shouldn't be the same. Like, so all of these problems are what we're trying to focus on. And today we've seen, right, like the vehicle and the battery for us that we're kind of doing is 5-year warranted. One rider is not going to be riding this 5 years. It'll keep changing. So how do you kind of change that as it goes?
So as a battery tech company who actually builds the battery grounds up would be able to provide such data.
Because there's just so much testing, so much data, so much processing, and so many edge cases we need to keep evaluating that all of this is happening on the road for us now. And integrating all of that for an IoT company or even for a standard analytics company, that understanding of how the cell is performing, to understand how electrically this performs, thermally this performs. I'm sure they could develop that themselves, but I just haven't seen that yet. So that focus on entire stack for battery, end to end, knowing every piece of this, how it links, then gives the edge over here.
This reminds me of, like in the past, how you've seen Japanese auto manufacturers, OEMs, approach problems and try to solve it from the design phase versus like an American automaker who would not approach those problems from a design point of view. It's something I see EMO doing. So you're following like the whole Japanese way of building from design and not try to solve for problems. Like, okay, now our battery pack has caught fire. Why has it caught fire? Can we fix for it?
Oh yeah, more mitigation than kind of starting from scratch. No, absolutely right. Like, I mean, Tesla talks a lot about this like first physics-based principle, or you can call it whatever you want. But it's more about just breaking down what actual the core is, and to really realize, yeah, just from a physics approach, I guess, because a lot of these are coming down to that, right? Like the market grows however it does, your go-to-market and all the business part is what it is. But a lot of this is just solving for, yeah, the underlying chemistry and how that's performing, and how those are very key like engineering challenges to solve for. So yeah, Rahul and I both have had a very rich background. He's been a very focused on the modeling, analytical, and really focused on cells, how they perform, how they degrade. He did that for General Motors for 10 years and for Sun Mobility for 2-3 years. And Sun Mobility's system is pretty amazing for what they do. And a lot of that is attributable to what he had kind of been able to establish from their air conditioning system, their battery pack integration system. And yeah, similarly, just seen this a lot at different companies for us to know that, okay, where we start itself is a little bit kind of iterated already. And then we're just going from there. Because even globally, the smaller battery packs that we have and even how they're scaling in size, they are up there in terms of the overall performance and what we're able to offer. So yeah, it's just a matter of scaling in terms of applications, keeping the modularity where you can implement different systems quickly, and then working with them to also implement the software system.
So let's talk about the market opportunity. How large do you see the market opportunity in India across different applications, and how do you want to approach it?
Right. So today, if you took the entire landscape, right, like all the vehicles that are basically charging, let's say even some of the diesel gensets that are all using fuel, let's say fuel using transport and energy systems, we feel like by 2030, if all of it went electric, it's literally $1 trillion market. Today we import
$1 trillion market.
Yeah, today we import over $150 billion in fuel. We spend almost 650 or $750 million in essentially building out engines and all of the systems that go into basically connecting the petrol system to the engine. And even with the most conservative estimates, that's $30-40 billion by 2030.
So it's massive.
The energy transition for India is, right, because it's not just a sustainability kind of like CSR activity here. Like fuel is our biggest import. It's our most expensive import, and it's from countries we don't like importing from. So it's an embargo established for various reasons. But the reality is that if we were able to even, let's say, import cells from China, which has its own issues, but a lot clearer supply chain because China just dominates in that globally. So there is no difference which country you are. If we can build an effective system around that, which makes the costs come down, which actually gives the TCO, there is no reason for us to be going electric today. And the costs are making sense today, right? Like it's just hard to convince a customer who anyway has low trust and confidence in this system to think that, okay, no, I can use this 10 years without going to the service station every month. That understanding is not there. And I get it, like we've seen that happen. So yeah, the market is huge. And even within this, our focus is the B2B segment first. So it's fleets on the hyper-local side, it's fleets in the e-commerce, in the delivery segment, people doing taxi cabs, all of that, right? High usage kilometers, because in that segment, it's a no-brainer.
High usage kilometers is a no-brainer.
Yeah, so even construction, agriculture, where there is like consistent amount of kilometers every day, they're doing upwards of 100 in some cases, 200 in some cases. There is really no thinking there. Like we should be all going electric right now.
This is where you are also seeing significant traction winning, right? So, so are you saying this is one of the only or major reason why you're winning with the fleet operators?
Yeah, so the fleet operator market, like even if I just took 2, 3, 4-wheelers, right? Like in the next 2 years, we see this a 2,000 crore open market, even considering all the orders in the market. Like I'm not saying that, okay, these are projections. These are current opportunities for batteries considering all the vehicles on road and all the vehicles these fleets are adding in the next 2 years.
2,000 crores.
Yeah, so let's take some of the 4-wheeler cab sectors who are replacing batteries and adding new batteries. All the fleet 2-wheelers who are, again, talking about going completely electric by 2030, like all the Zomatos and the big baskets of the country. And then you have 3-wheelers, which is slowly ramping up, but still a major section of this. All of that is essentially looking at a very, very strong TCO to now scale across everything. Because the world of experimentation, sadly, is over in the sector. Like today, now we need to get something that just scales. There's a lot of money. And just get to like 1 million units, right? Like none of us have really got there except a couple of companies. But how do we get to 1 million systems in the next 2 years, reliably implement something that scales across this country, then goes outside? And even for that matter, you mentioned the whole Japanese principle, right? Like the Japanese had an edge in the ICE world.
Yeah.
They're the reason the 80s and 90s became Hero Honda, Kinetic Honda, Yamaha Honda, and all these other things that happened in India and the rest of the world. They're not doing that in the electric vehicle segment for light mobility.
Yeah.
This country has a shot. The next 2 years are very critical because if we build these right, we're already seeing interest from even global two-wheeler companies, global three-wheeler companies. Passenger cars will keep out because there's a lot of innovation in US and China that actually is a little bit ahead of us. But construction, agriculture, two-wheelers, three-wheelers, energy storage for developing worlds, these have nothing to basically be really very focused on, right?
And EMO can serve all of these markets.
That's
Are you
the
already
focus.
serving?
Yeah,
Have
we've
you done
started with
pilots?
two-wheelers. We've started building a lot of samples for different customers for three-wheelers and for four-wheelers. We have almost 25 odd prototypes in vehicles testing. The idea is that within the next 6 to 9 months, actually scale to production, start assembling these on a mass scale, and just kind of scale all across the board.
So let's also talk a little bit about your go-to-market approach, right? So you have OEMs as customers. You also have end users as customers, which is slightly odd, and would love to know why you are going towards that way.
Right. So today, OEMs obviously have the need to just put a battery pack in vehicles, right? Because without it, it doesn't work. You need electric to get the vehicle right. So a lot of them might want their own systems. A lot of it might get it from somebody else. But no matter what happens, a lot of them would always want it as cheap as possible. It doesn't matter what tech you give. Just
The
this
OEMs.
market, the OEM always wants it as cheap as possible because very competitive market, very strong level of competition from all sides. So cost is key.
So you're saying if you take EMO battery, the life cycle would be double. We have all of this data. It's going to last for perhaps 8 years. You're saying they're like, this is good, but I need a cheap.
There's a target. There just is. Like you need to be able to build vehicles at a certain price. Just overall, it's hard to get that right. Subsidies have gone away, so it's a pure play cost kind of focus game, right? So within that segment, no matter what you're able to offer, the specialties that you're able to offer just become a bigger selling point to get better volumes. So for them, they're thinking that they are using you not to increase their BOM cost, but to just get more volumes at the same cost. Because they think that this can be a branding point for us. And now we can go to customers and actually sell them better charging, better life, alleviate their trust, improve their confidence, and supply something. And that's great, but it's also just not that great for us because then the margins are lower, you're being squeezed by OEMs, you're being locked into OEMs, and all of that's happening. But the end user is paying rental. The end user is paying a certain EMI every month and paying
Who
per
are these
delivery.
end users like? Can you tell
So the end user primarily for us today is Big Basket, Domino's, certain other fleets in the kind of hyper-local delivery segment through
How are you
multiple
selling
fleet
to them?
operators. Yeah, so today what we do is we'll go to a fleet operator like Big Basket, tell them that this is a proposition, let us test on 2 vehicles. Let us just set up one fast charger for you through whoever. Let us implement this as a system and you'll see the improvement. So now with our battery pack, they're essentially charging for 40 minutes a day and getting 120 kilometers range, essentially from it, charging twice for 20 minutes across their tea breaks or their delivery breaks, and now doing upwards of 200 kilometers even while charging for an hour total across the day. So the idea of using very low power to do it, the idea of getting so many kilometers per charge, and then also getting this life cycle improvement, now goes to the end user like a Big Basket, thinking that, okay, I'm already at a downtime of 30%, but I still need more riders. So I'll improve this uptime to 95%, get my vehicle's asset utilized 18 hours a day, and now basically also reduce my rider requirement and then eventually reduce my delivery cost. They're seeing the improvement in TCO because the rental is lower for them. They will then basically actually pay more over time for a better solution because they're seeing the final life improvement.
So
the OEM is not seeing it.
More than the OEM, the end users like Big Basket, Domino's, your customers.
Because it hits them. Like the end user is getting hit, right? Like they're paying lower delivery costs because everything in the whole ecosystem is cheaper and the uptime is 30% better. So now overall we need fewer vehicles, they're better utilized and for longer.
So they appreciate the tech that you build and the value that you bring to the table more than OEM, which is why you're selling to both. But how do you sell to like a Big Basket?
Right, and their incentive is also highest, right? Because an OEM is just selling more vehicles. Like for a traditional OEM, selling an IC versus an EV doesn't matter. They just want to sell vehicles. Like so, the incentive for a Big Basket to go electric and reduce their expenses is much higher. So today we go to Big Basket. We're already tied up with a couple of vehicle OEMs. present them options that, okay, you can establish these chargers, you can put these batteries with all your vehicles, and you'll get this improvement in TCO. They now pay us a rental for the battery system on rent. We work with the bank to finance the battery, and we're essentially kind of leasing, subleasing this whole model. But the idea is that we scale as a tri-party, right? Like the OEM, us, and the fleet operator now are a level playing field. It's not like we're a supplier by any means.
Okay.
We are an energy partner for both of these individuals.
Okay.
Yeah.
Okay. So you stop being a supplier or a vendor.
It's very critical to not be a vendor, because that's just a not nice word. Like yeah. The idea is to be a partner here, right? Like you want to be scaling with the end user. You make sure that the end user pan India now uses your system. Like there's 500 big basket hubs. All their energy is controlled by us. Like discharge side and charge side, we are controlling it. We give very detailed data to big basket on how they optimize their usage, reduce their usage, increase kilometers per usage. That whole understanding is not something a vehicle company has or a big basket has. That is coming from us because we have all that data.
It also puts you in a position of power, right? So a big basket could go to the OEMs, a couple of OEMs that they partner with, and say, hey, I want EMO batteries.
Right.
Are they saying that already?
Yeah, that's it's actually been pretty interesting to see that a lot of the players we weren't working with first are now coming back to us from the OEM side, because in the background, now that we're scaling on the fleet side, there is a certain amount of usage that's already happened and a certain understanding that whatever we were using before this was actually not as good. We've been reducing costs, but we're actually seeing better performance, seeing better service, seeing better usage. So yeah, it's been pretty amazing to see that today we are the kind of partner with the fleet, and both of us combined are now going to OEMs and saying that, yeah, we have to establish this linkage here, which is missing. And yeah, that's already happened with a couple and continues to happen, I think. And that whole, again, that tri-party relationship to maintain on a level playing field is very critical for us, because otherwise it starts getting a little bit skewed, and that then becomes a problem for anybody's growth. And this is the bigger issue with this whole segment, right? It's not just us. You'll always try to be labeled as a packaging or assembly company, which again is a misnomer to a certain extent for some companies, not for all. But the idea is to essentially move beyond that to a system where even the Domino's and even the big baskets of the country and all of those kind of companies combined are saying that, no, we want to move to a software and energy system and a vehicle system. Those are separated now overall.
Interesting. So let's talk about your goals as EMO, right? In terms of what kind of revenue targets are you looking at, and what have you achieved till date, and how do you envisage the next 3 years for you?
Yeah, so this year actually was pretty amazing scale for us. We did more than $500,000 in sales already, another half that we were supposed to commit to, but just limited a little bit by scale. And the next year we aim to do at least $20 million in sales. We already have the orders. We have a detailed order book to how to supply those each month. And the only pending part of this is the scale that is required from an initial working capital and resource side to essentially set up CapEx. For us, that becomes the biggest bottleneck, because it isn't like just the software where we can scale quickly without.
So you're saying this year you would hit a 20 million?
FY25, yes.
FY25 you'll hit a 20 million sales target, so
right.
Roughly about 170 crores.
Yeah, that's an order book we essentially have already in place. And
you already have the orders, you just have to
we just kind of need to service it and supply it. And yeah, the companies are doing well. We just need to kind of meet their targets now, right?
So what happens in 27, 26, 27? How do you envisage the growth?
So as a company, the way this is going, and if I take all those segments combined, right, the 2, the 3, the 4-wheeler, all their sales should get us to a level where we're essentially doing almost 1,000 crores in revenue in that period, where this gets us to a point where, we're a $200 million kind of revenue, like everything else combined, just some of the expenses, and we're actually profitable at that point, right? Like we're not really burning money by any means, because that scale for us becomes very quick once we actually make decent margins. We're already upwards of 10%. We should be upward double of that within the next 6 months. Nice. And once that happens, you really see this opening up even globally. Like today, there's enough opportunity to do even 2,000 crores in India, because there are actually those requirements. It's just that it's so fragmented within this, because all of them are assemblers and all of them are doing the same thing, that it's really not a very unified, clean approach to essentially assemble and provide like a high quality system. So
at a 200 million revenue, that would make you a unicorn.
That should be the case, because there's really not been that many in this segment. And it's also because, again, unification, that scale hasn't happened, right? Like there's a lot of okay, there's a battery company in Ahmedabad, there's like 10 in Delhi, there's 10 in Bangalore, there's 10 there. This segment will consolidate. Like you're already seeing this in two-wheeler OEMs, you're already seeing this in three-wheeler OEMs, and even within battery, it's going to start happening. The focus for us is to maintain very key OEM relationships, very key fleet relationships, and for that to happen, the groundwork's already laid out. We just now need to scale to where we can very comfortably be hitting that kind of revenues within that period, because there is very clear.
It's very interesting in this world, like today's day and age of VC funding and startups, where how do you become a unicorn, right? And usually when we talk to founders, they are saying, hey, but in 3 years I'm going to be a unicorn, I'll be $1 billion valuation. But when I asked you that question, you said, hey, in 3 years I'm going to be 200 million, and I suggested that could perhaps be the unicorn.
Yeah,
status,
secondary, right? Like the idea is to get
the unicorn status. Saying, like, hey, fundamentally I'll be 200 million. And there are companies like, say, Exicom and those who've gone public. Right. And even if you just extrapolate that at that level, you would be $1 billion plus.
Yeah, that's over a 6x multiple. So that's the idea. Because and again, these are not projections, right? Like today, there are like already 1 lakh two-wheelers that went out. There's already 10,000 like four-wheelers in fleets. There's so many three-wheelers all across the north and even now propagating the south. All of these is a target market for us. Like we want to get batteries into wherever you need high life cycle and high performance. We're not restricting ourselves to something niche. As long as it meets this use case for us, we go there. And we're in touch with enough companies to know that their order books support this kind of scale. So it's, So
you're saying it's just a matter of time and you would hit the 200 million in revenue in the next 3 years.
You make it sound simple, but the idea is that like over the next 3 years, the consistent scale going from let's say 1,000 to 10,000 to 100,000 units allows that. And the scale of manufacturing to support that is something we have a lot of experience doing. Having set up Ola's factory, Rivian's factory, Sun Mobility, Ather's factory. And the scale required to support the supply chain side of this, the software scale is also there because we've been very focused on getting that kind of experience to the team. And the factory today has like 40 people. It has like a lot of capex already well established and a very clear plan to how to scale to 1 million units. So it's just really executing a very detailed plan out over the next 3 years, which then gets us to that scale.
So that's a massive target to hit like a 200 million revenue, right? What we've talked about money, we've talked about how this would make you a unicorn. But another mission of Transition VC is also carbon offset. How are we solving for the climate goals that India has and our journey towards net zero? So what does $200 million in revenue translate in terms of carbon emissions that you as EMO would contribute towards, carbon offsets that you would contribute towards?
Right, so over 2 years from now, we should have more than 7 lakh odd units on the road across all these sectors. And the usage for our vehicles is obviously quite high. So we anticipate over 1 million tons of kind of CO2 being offset, right? Because each of these vehicles,
of carbon offset.
Each of these vehicles are being used almost 2,000 kilometers a month. They're basically the most high usage kind of utilization there is. So for us, that's the focus first in the next 3 years. And then beyond that, actually scaling in numbers across the B2C segment gets like another 10 million over the next 5 years, which is the objective. Because the biggest contributor for this across the space is the mobility segment. The industrial and all the other, the HVAC segments come later. But if we can start offsetting the two-wheeler, the three-wheeler, the really large vehicles first, that's an incredible amount of work. And then again, like that's barely like 2-3% in the global, like in the actual national scheme of things. So the objective is to keep going 1 million at a time to a certain extent and then go from there.
Wow. So in 3 years, the target is 1 million tons carbon offset, hit the 200 million revenue, and be one of the first EV unicorns of India.
100%. And the scale required to achieve that, the technology required to achieve that is actually something we have now. We are actually like putting in all the resources together to get that right. It's just a matter of execution and actually getting our kind of proof of concept that we've established to the right OEMs and to the right end users.
That's amazing. Great. Thank you so much for your time. Thank you for all the insights, Shitanshu.
Looking forward.
Love chatting with you, and I'm sure we'll do a lot more podcasts in the future.
Okay, thank you so much.